Hello and welcome to the special edition of AWS Innovate, which we have created for you. I hope you will find the sessions we have put together for you useful and will be able to relate it to the use cases and requirements in your organization. In this session, we will look into how and why you should be building a data lake and how you can use AWS Lake Formation to create data lakes on AWS. My name is Unni Pillai, and I'm a specialist solutions architect with Amazon Web Services in Singapore. On a day-to-day basis, I work with customers across Asia to help them build analytics platforms and data lakes on AWS. So let's get to it. In this session, I'll give you a quick introduction to data lakes and why they are important, and why you should consider building them. During the re:Invent conference at the end of 2018, we introduced a new service called AWS Lake Formation. We will take a look at why we created this service and also look at different components of AWS Lake Formation and understand some of the key features that the service provides. The volume, variety, and velocity of the data continues to increase on a day-to-day basis. The types of data set are getting bigger and more diverse day by day. The customers that I talk to tell me that data is coming from many different sources and applications like ERP, CRM, and other diverse set of data sources, and they end up in silos. The volume of data that we are dealing with is also growing fast. Machine-generated data and logs are growing much faster than business data, thanks to network-connected smart devices, microservices architecture, and the growing popularity of DevOps culture. Data platforms live for a long time, on average at least 15 years. When you're thinking of building a data platform, you need to think not just for your current data needs, but also the data needs over the next 15 years. The amount of data that you'll be dealing with will be multiplied 10 times every 5 years. So for the data platform that has to run for the next 15 years, you need to design it in a way that it will scale 1,000 times from what it is today. Multiple teams want to access data collaboratively for various business use cases. These use cases can range from business reporting to ad hoc analysis to deep insights using machine learning. In today's world, technology and business teams want the flexibility to self-onboard and share the data. They also want the ability to analyze the data in real time and be able to reach and analyze at massive scales. And they want to do so in a manner that adheres to the security and compliance requirements enforced by their compliance and security teams. And that's why many customers today are moving towards the data lake architecture. Data lake is an architectural approach that helps manage multiple data types from a wide variety of sources, both structured and unstructured, through a unified set of tools. It makes data readily available to be categorized, processed, analyzed, and consumed by diverse groups within an organization. Since data can be stored as is, there is no need to convert it to a predefined schema, and you no longer need to know what questions you want to ask to your data beforehand. More people are running their data lakes and analysis on AWS than anywhere else. We have customers like FINRA, who is processing and analyzing 75 billion records every day. Netflix, on the other hand, is improving the quality of their content to their end users by making data-driven decisions and using machine learning to give personalized recommendations to their viewers. Data lakes allow you to break down data silos and bring data into a single central repository. You can store a wide variety of data formats at any scale and in low cost. You can work with structured, semi-structured, and unstructured data. Data lakes provide you with a single source of truth and allow you to access to the same data using a variety of analytics and machine learning tools. One of the most important things about data lakes is that they let you store huge volumes of data, and this makes it cost-effective. A well-designed data lake is cost-effective to run and maintain. With AWS Cloud, it has never been easier and more cost-effective to collect, store, share, and analyze data. Data teams across the world love AWS' unmatched array of analytics services. Amazon Athena for unstructured and ad hoc querying, Amazon EMR for processing a vast amount of unstructured data using popular open-source frameworks, Amazon Redshift for data warehousing, Amazon Kinesis for processing streaming data, Amazon QuickSight for building BI dashboards, and Amazon Elasticsearch for running hassle-free Elasticsearch clusters. Customers today are looking at highly scalable, available, secure, and flexible data store that can handle large amounts of data, which makes Amazon S3 the #1 choice as a data storage layer for data lakes on AWS. But building a data lake is not easy, and it takes a huge amount of time and a lot of work to build something that is usable. It turns out there are a lot of steps that are involved in building a data lake. First is obviously setting up a storage. Data lakes hold a massive amount of data. Before doing anything else, customers need to set up storage to hold all of that data. If they are using AWS, they configure S3 buckets and partition it. If they are going to do this on-prem, they acquire the hardware, set up large disk arrays to hold all the data for the data lake. They then have to move the data. Customers need to connect to different data sources on-premise, in the cloud, and also with their IoT devices. Then they have to move the data. Customers need to connect to different data sources on-premise, in the cloud, and also to IoT devices. Then they need to collect and organize the relevant data sets from those sources, crawl the data to extract the schemas, and add metadata tags to the catalog. Customers do this today with a collection of file transfer and ETL tools like AWS Glue. Next, they must clean and prepare the data. Data that is collected must be carefully partitioned, indexed, and transformed to columnar formats to optimize for performance and cost. Customers need to clean, deduplicate, and match related records. Today, this is done using rigid and complex SQL statements that only work so well and are difficult to maintain. This process of collecting, cleaning, and transforming the incoming data is complex and must be manually monitored to avoid errors. Once that is done, they need to configure and enforce security policies. Sensitive data must be secured according to compliance requirements. This means creating and applying data access, protection, and compliance policies to make sure you're meeting requirement standards. For example, restricting access to personally identifiable information, or PII, at a table, column, and row level, encrypting all the data, and keeping audit logs of who is accessing the data and when. Today, customers use access control lists on Amazon S3 buckets, or they use third-party encryption tools and access control software to secure the data. And for every analytics service that needs to access the data, customers need to create and maintain data access, protection, and compliance policies for each of those services. For example, if you're running analytics against your data lake using Amazon Redshift and Amazon Athena, you need to set up access control rules for each of those two services. Making it easy to find data. Different people in your organizations, like analysts and data scientists, may have trouble finding and trusting data sets in your data lake. You need to make it easy for those end users to find relevant and trusted data. To do this, you must clearly label the data in the catalog of the data lake and provide users with the ability to access and analyze this data without making requests to IT. Today, each of these steps is time-consuming because a lot of it is done manually. Customers can spend months building data access and transformation workflows, mapping security and policy settings. They also spend a lot of time configuring tools and services for data movement, storage, cataloging, security, analysis, and machine learning. With all these steps, a fully productive data lake can take months to implement. Let's take a look at what are the usual steps involved in creating a basic data lake setup. You start with finding and identifying data sources from where you want to ingest the data from. Then you go ahead and find methods to ingest that data into your data lake. Next, you have to create the storage buckets in S3 to store the data. You configure the bucket policies to secure the buckets on the storage layer. Using Glue, you'll create the tables and columns mapping so that you can use those data sets. Then create ETL jobs to load and clean that data. Then you'll create IAM policies to provide access to the underlying AWS resources. And finally, configure the analytics services to grant specific user permissions to tables and columns. All of this was just for one data set, and you end up rinsing and repeating this for all your data sets in the data lake. This method of creating data lakes is manual, error-prone, and very time-consuming. Over the years, we have received feedback from our customers and created AWS Lake Formation, which takes away most of the heavy lifting that the customers perform today to build their data lakes. AWS Lake Formation automates many of these steps we discussed, allowing customers to get started with just a few clicks from a single unified dashboard. With Lake Formation, you can discover, ingest, move, store, catalog, and clean your data faster. Once the data sources are created, you can define policies for security, governance, and auditing in one place and enforce those policies for all users and all applications. With Lake Formation, you can build data catalog that describes available data sets and their appropriate business users. This makes your users more productive by helping them find the right data sets to analyze. By providing a catalog of your data and consistent security enforcement, Lake Formation makes it easier for your analysts and data scientists to combine multiple analytics tools like Athena, Redshift, and EMR across a diverse set of data sets. With just a few clicks, you can set up the data lake on Amazon S3 and start ingesting data that is readily queryable. To get started, you go to the Lake Formation dashboard in the AWS console, add your data sources, and then Lake Formation will crawl those data sources and move the data to your new Amazon S3 data lake. Lake Formation uses machine learning to automatically lay out the data in Amazon S3 partitions. Change it to formats that are faster for analysis, like Apache Parquet and ORC, and also deduplicates and finds matching records to increase data quality. From a single screen, you can set up all the permissions for your data lake, and they will be implemented across all the services accessing the data. Analytics and machine learning services like Amazon Redshift, Amazon Athena, and Amazon EMR. This reduces the hassle in redefining policies across multiple services and provides a consistent enforcement and compliance for those policies. S3 acts as a core foundation for the data lakes. You have an option to registering your existing S3 buckets using Lake Formation, or you can also tell Lake Formation to create new buckets. Data in S3 is stored in formats that best suit your needs, and it can be moved around if you need portability. You can keep the data in Parquet, JSON, ORC, and move them across technologies as per your needs. You have complete control over the data. Ownership and security of data remains with you. We provide blueprints in Lake Formation. Blueprints are predefined templates that make it easy to get data from sources. In Lake Formation, we ship with blueprints for relational databases so that you can extract data from any flavor of RDS or Amazon Aurora databases. You can also connect to databases running on EC2 instances. We have blueprints for other data sources like Kinesis Firehose. We also have predefined templates for building schemas and partitions for CloudTrail logs, ELB logs, and a bunch of other log types. You can also add custom recognizers in Glue to get this work for you. Lake Formation is built on the openness of Glue. With the ability to discover the schema and metadata attributes automatically, we support a one-time ingest into data lake and also let you incrementally load data into the lake. We wanted to make this as simple as possible for you to get started with building data lakes. Using blueprints is extremely easy. As a user, you point it to a data source and tell us the location of the data that is in your data lake, and specify how often you want to load the data. Then the blueprints go ahead and discover the data source automatically and convert the data to a target schema. It then automatically partitions the data based on the partitioning schema specified. It also maintains the bookmarking information on what is processed. Blueprints heavily leverage on the functionalities of AWS Glue. We use Glue crawlers and connections to connect to the source, that raw data, and that needs to be ingested. We use Glue code generator and jobs to generate the ingest code to bring the data into the data lake. We leverage the data catalog for organizing the metadata. We have added a workflow construct to stitch all of this together, like crawlers, jobs, and allow monitoring of individual workflows. They are just a natural extension of AWS Glue capabilities. In Lake Formation, we have also added the capability for you to perform data cleansing operations. This is the same technology that we use internally in Amazon.com. We use machine learning to do duplication of data and to link data using fuzzy matching to see if it's the same data. You can tune the results, and once satisfied with the outcome, you can create jobs that will run on a schedule to clean and prepare your data sets. Security. This is an important aspect of Lake Formation that will let you save massive amounts of time. Anyone who has built data lakes manually knows it takes a huge amount of time to get security right. As users, we think about databases, tables, rows, and columns. But the reality is that data in our data lakes are stored as S3 objects, and security for those works with NACLs and bucket policies. Figuring out the mappings between all of this is extremely complex. In Lake Formation, we have tried to simplify this and turn the problem upside down. In Lake Formation, the data access and security policies live next to the data catalog, so that you can control who can access the data and how they talk to the data lake. This integrates directly with Athena, Redshift, Glue, EMR, and Amazon SageMaker. So users can talk to these services directly, and these services will talk to Lake Formation to get the right set of permissions and credentials that allow you to access the data. You will be able to grant and revoke permissions on tables, columns with AWS Console. With this, you don't have to deal with the underlying bucket policies for S3 buckets and IAM roles for AWS Glue. Lake Formation also lets you audit data access from a central location. You can see the permissions assigned to users on a database and table level. This can be used to manage security for all the data sets in your data lake centrally. The security permissions in Lake Formation not only allows you to control table-level access, but also column-level access. There is an example of table schema for Amazon reviews. User 1 here only has access to a subset of columns, while user 2 can access the entire table. You can access and assign permissions to both IAM users, roles, groups, and Active Directory via federation. When the users run a query using any service that integrates with the Lake Formation on a table, let's call it table T, the service requests short-term credentials to access the underlying object comprising data in table T. Using those credentials, services fetch the underlying data from S3 and process the data to run the query. This approach removes the need for a middleman in the critical data processing path. Using the console, you can search the metadata for your datasets to explore and better understand your data. It also lets you launch an Athena query from a table directly from the catalog. Security is at the heart of Lake Formation. It gives you the ability to audit changes to your security posture by providing you access to the audit logs. You can also send events to CloudWatch when a specified event such as data ingest or catalog changes happen. Now let's put all of this together in an example and see how it will work in real life. First, we'll use blueprints to ingest data. You can use blueprints to bring in data as a bulk load option or continually as the data changes from the source. Here, we use incremental blueprints to point to a WordPress database to bring in the user profile's metadata. In the next screen, we'll provide a name for the blueprint, specify the database connection, and type in the tables that will be ingested. On the bottom of the screen, you can see that we are also specifying a bookmark for the table. The table name is WP users, and we are calling it, the column ID is ID. This column will be used to load records incrementally. Loads are processed asynchronously. You can monitor their progress through a console and dashboards. In the screenshot, you can see that the job is successful and 12 tables were imported into the data lake. The ingested user data appears as tables in the data lake. We use the AWS Glue crawlers to discover the schema and metadata attributes automatically. At this stage, the tables will appear in the AWS Glue data catalog. You can specify granular permissions to share the data securely with principals like IAM users, IAM roles, AD users, and groups. Integrated AWS services like Athena will allow access as per the specified permissions. When accessible, users can easily query the data in situ. When inaccessible, the tables do not appear in the data catalog itself. There is no additional charge for using Lake Formation. You will only pay for the services used by Lake Formation. For example, Lake Formation uses the Glue data catalog and jobs and crawlers in AWS Glue for loading data to the data lake. You will get charged for using Glue as per its public pricing. Similarly, for data that is stored in Amazon S3, you will get charged for storage as per S3's public pricing. Here is what two of our customers had to say after hearing about Lake Formation's launch. Change Healthcare said, Lake Formation will help dramatically reduce operational load by provisioning a central point to control their data lakes. While Fender, the guitar company, said, they can now spend more time deriving value from the data rather than doing heavy lifting by manually building data lakes. With that, we come to an end of this presentation. I hope you enjoyed the session and found the content useful. I'd like to thank you for attending this session and sticking around until the very end. Please take time to provide feedback on today's event so that we can improve the experience for you in the future. And please feel free to visit the demo arena, where we have some really cool real-life machine learning demos for you. Lastly, if you'd like to validate your technical expertise with AWS and gain industry-recognized certifications, you can follow the links on the screen to find out more about it. Have a good day, and thank you.